we move on to the product. So when you say product of functions, you can really see a dot in there, or sometimes you won't see that one. Sometimes you will be seeing like this, or even like this. So whichever is the notation is, you must know that this is simply equal to f of x times g of x. Now, let's have the example in here. So example is, that's the same thing. So f of x equal to x squared plus 2x plus 1, and the g of x equal to x plus 1. So how do we do multiplication in here, or the product? Now, in multiplication part, there are many ways for you to do that one. So first, let's try to have this first method. So I'll be touching all the possible method therein. So anyways, you can choose which you are comfortable with and go with that. This is really a uh, free class. I mean to say you can choose your own way of solving that certain problem. And of course, it must be that you are using it correctly so that you'll come up with a correct answer. Otherwise, you might be coming up with a wrong answer. So you have to be careful on that. So we have here f times g of x. This is simply saying f of x times g of x. So there you go for the notation of the product of function. Now, again, you are going to replace the f of x and the g of x there. So we can have x squared plus 2x plus 1 times your x plus 1. So the first method that I'll be introducing is your distribution or distributive method. So again, I guess everybody knows that one. You will be distributing each of the term to the other group. So how do I do that? So let's start with this one. So we'll choose on, anyways, you can choose on which you wanted to distribute with to the other group because multiplication is commutative in nature. Now, if I'm choosing on the x squared plus 2x plus 1, in which I will be distributing that one to the other group, so here is the thing that you are going to do. So first, we'll start distributing the first term, which is x squared. You distribute that one on the other side. So that means x squared times x now will be x cubed. And then another one, since there are two terms on the other side. So we have x squared times 1. That will be x squared. Now, we're done with the first term. Let's go to the second term. Second term is 2x. And I'm going to distribute that one on the other group. So we have 2x times x. That will be a positive 2x squared. Next one, we are still on 2x. We are distributing that one on number 1. So 2x times 1, that will be equal to positive 2x. Now, we're on the last one or the last term in there. So we are distributing that one again to the other side. So 1 times x, that will be positive x. And then 1 times 1 in there, that will become a positive 1. Now again, combining like terms, if you cannot really combine, or if one of your term in there doesn't have a common or a like term, then you just simply copy, just like your x cube. We don't have any other x cube in there, so we are to simply copy x cubed. And then for the x squared, we have the x squared and 2x squared. We can simply add that one. That will be giving us 3x squared. And then we have the 2x plus x. That will become a 3x. And then we don't have any other constant aside from 1, so we simply copy that one. So this is now our answer to f of g of x using the distributive method of multiplication in there. Now let's go to the other method. Now, other method could be, you can actually do this one using the long multiplication method. So what do I mean by the long multiplication method? So we are to write this one vertically. So we have x squared plus 2x plus 1. for the f of x, and the g of x will be x plus 1. As you have noticed, I'm really aligning my like terms in there. So we go for the multiplication. So we have here, we are actually doing multiplying similar to your numbers. So meaning we are to check on numbers itself. We are really multiplying that one digit by digit. So that's the same thing. But here we are doing that one terms by term. So we'll start with 1. So 1 times 1, that will be 1. That's a positive 1. And then we go for 1 times 2x. That will be a positive 2x. And then we go for 1 times x cubed. That is a positive x cubed. What did I say? I mean x squared. Okay. Now next we go for the x. We're done with 1 in there. We go for the x. So we have x times 1. This is now x. And that's a positive. And then we have 2x times x. We have that one as the 2x squared. And then we go for the x times x squared. That will be a positive x cubed. Now we're adding. So everything really is similar to the process of multiplying numbers in there. So we have here plus 1. We simply bring down that 1 because we don't have other constant in there. So we're bringing that down. So we have 2x plus x. That will be giving us 3x. And that's a positive. And then x squared plus 2x squared. That will be a 3x squared. And that's a plus. And then we have your x cubed will be brought down because that is only the term in there. We don't have any other x cubed in there. So final answer is for the f times g of x, that will be equal to x cubed plus 3x squared plus 3x plus 1 using your long method of multiplication. We go to another method in which you might be loving this one. So I am literally introducing every possible method therein in which I know. So this is actually what we call as the box method. Other people call this one as the lattice multiplication, but either way, they mean the same thing. So how do we do our box method? Now, for the box method, we are simply constructing a table in here. Now, the table contains the terms of your function. So your first function in there, you can have it as the header of the table. So you can write it like this. So we are actually writing per cell on the table each of the terms. So meaning each term there will go to cells and the other one will go to the other cell. So how do I do this? So we have on the first function, the f of x in there, we have the first term as x squared. By the way, when you say terms, they are your variable or constant or variable with constant separated by a plus and or a minus. So that is what you call as a term. So we have here x squared is the first term. So I will be constructing a table. Sorry if I cannot draw the one straightly because I've got a very glossy pad. So we have here x squared. Okay, I'm trying my best here. Okay, this is now the operation is multiplication. So the next one is 2x. Now, if your term in there contains a negativity, of course, you will be bringing that with you. So meaning to say, if that is minus 2x, you will be writing there a negative 2x. But since we have a positive 2x in there, so we will be copying the 2x. And then we have another one that's a positive 1. Now, once we have all those, we are going to go for the second function. And then we have your first term is x. There you go. And then the second term is 1. Now, by the way, if your exponent in there is missing, when you say missing, if the arrangement in there, let's say for example, highest exponent is x, I mean 2 for the x squared, and then it jumps right away to plus 1, so the x in there is missing, you are going to fill this up here, this part with a 0 to indicate that your x in there is missing. Anyways, we'll have an example on that one on my next video. So let's continue with this. So we have here, you are only doing the box method here by simply doing the multiplication table. This is really the multiplication table. So how do we do that? We simply multiply your first term on the first column to every term on the header in there. So that means x times x squared will have x cubed. And then x times 2x will have 2x squared. And then x times 1, we have an x. Next, we go to the next term. We have 1. Multiplying that to the header, so we have 1 times x squared. That will be x squared. 1 times 2x, that will be 2x. And 1 times 1, that will be 1. Now, it must be that this one here, the entire term there, does not contain a missing um, variable in there. Just like what I've mentioned in here, that we missed the x in there with an exponent of 1. So the reason behind that is we will be doing a diagonal adding here. So in order for you to have a very smooth addition later on, you'll have to complete your terms in there. That is why if this is the case, we are simply writing a 0 in here just to fill that up, just to fill up the missing term in there. Anyways, we'll continue. So how do we do this one? What will be the next move in here? Now, we are adding diagonally, so we are doing the first diagonal in here. This is the only diagonal that we can, no, there is another one, I mean. So this is the first diagonal, and this is now the second diagonal that we can create. Now, those that are not in a diagonal, or those that is not contained in a diagonal, or we cannot come up with a diagonal that contains two or more terms, we can simply just copy that one. So we are not going to include the header and so with the first column. What we are really including is the inner result or inner terms. That's the result when you multiply the first column and the header in there. So how to visualize that one? We simply copy your x cubed, which does not contain any other term in a diagonal. So we have x cubed. And then those that are in a diagonal, we are simply adding those terms. So we have x squared plus 2x squared. That will be a positive 3x squared. And then we have 2x plus x. That will be a 3x. And then the one there is part of the solution. So we simply copy that one. So this is now your multiplication on f of g of x using the box method. Okay, if you find this one comfortable, then you might consider having this one. But anyways, you are free to choose your own method in there as long as you're comfortable with it, then be it.